If the past really happened, where is it now? Is it sitting somewhere safely stored, or is it slowly disappearing as the universe moves on? A broken cup never fixes itself. Heat never flows backward. So here's the unsettling thought. If everything is always falling apart, how can the past still exist at all? And if entropy keeps rising, is the universe quietly erasing history while we watch? Outline 1. Why time refuses to run backward. Imagine watching a cup fall from a table. It hits the floor and breaks into many pieces. You never feel surprised. But imagine the opposite. The broken pieces suddenly jump up, gather themselves, and land gently on the table as a perfect cup again. That would feel shocking, almost impossible. The strange thing is, the basic laws of physics do not clearly forbid that second scene. The atoms know how to move both ways. So the real question becomes very curious. If the laws allow it, why does time refuse to run backward? Let's start with something very small. At the level of atoms, motion is simple. Atoms collide, bounce, vibrate, and exchange energy. If you filmed two atoms colliding and played it backward, it would still look like a perfectly valid collision. Nothing seems to care about direction, forward or backward. The rules still work. So at the microscopic level, time does not have a strong arrow. But now zoom out. Look at many atoms together. A glass, a room, a human body. Suddenly things change. We see patterns that only go one way. Ice melts in a warm room. It does not gather heat from the air and refreeze itself. Smoke spreads across a room. It does not squeeze itself back into a cigarette. This one-way behavior is not coming from a new law. It comes from statistics, from probability, from numbers that become overwhelming when many particles are involved. This idea is called entropy. It sounds complicated, but it is not. Entropy is just a way to describe how spread out things are, how mixed up, how many different arrangements are possible. A neat system has fewer possible arrangements. A messy system has many more. And nature strongly prefers the messy ones, simply because there are more ways to be messy than neat. Think about a deck of cards. A brand new deck is perfectly ordered. All suits aligned, numbers, in sequence. That is a very special arrangement. There are incredibly few ways for the deck to be perfectly ordered. Now shuffle the cards. After just a few shuffles, the deck looks random. There are astronomically many random arrangements. If you keep shuffling forever, you will almost never return to the original order, not because it is forbidden, but because the chance is absurdly tiny. Time moves forward because probability pushes it that way. Now connect this to everyday life. When you drop a cup, it breaks because the energy spreads out into cracks, vibrations, sound, and heat. That energy disperses into many tiny motions among many atoms. To reverse that, every single atom would need to move in just the right way, at just the right time, to bring the cup back together. One atom being slightly off ruins everything. With billions of atoms involved, the odds are so small that for all practical purposes, it never happens. So time's direction is not enforced by a strict rule. It is enforced by overwhelming odds. Forward is easy. Backward is unimaginably unlikely. Now think about memory. Why do we remember the past, but not the future? A memory is a physical thing. It lives in the brain as a pattern of connections, chemicals and electrical signals. Creating a memory means changing the brain from one state to another. That change increases entropy. It produces heat. It uses energy. You cannot form a memory without spreading energy around. The act of remembering requires time to move forward. This leads to something deep. The past exists for us because records exist. Photographs, fossils, written words, brain states. All records are physical systems that store information, and storing information always increases entropy somewhere else. You cannot keep a perfect record without paying a price. The universe pays that price by becoming more disordered overall. Now imagine trying to observe the future the same way. You cannot have records of events that have not happened yet, because records require entropy increase, and that increase points forward. The future has no physical traces yet. The past does. That is why the past feels fixed and the future feels open. Consider footprints in sand. When someone walks across a beach, their feet compress the sand, leaving a clear trail. Wind and waves slowly erase it. The footprint exists because energy was spent creating order in one small region, while disorder increased elsewhere. Over time, entropy smooths everything out. The footprint fades. The beach forgets. This forgetting is part of time's error. Information about the past leaks away. Now ask a strange question. Does the past still exist? In one sense, yes. The atoms that once formed yesterday's world still exist today. They just moved. They rearranged. The past is not stored as a complete movie somewhere in space. It survives only in scattered incomplete records. And those records are constantly being degraded by entropy. This explains why you cannot perfectly reconstruct the past. Even with the best technology, you lose information. Heat flows into the environment. Tiny details vanish. The universe is not keeping a perfect backup. It is slowly erasing the fine details, leaving only rough patterns behind. Time refuses to run backward because running backward would require information to spontaneously reappear. Heat would need to flow from cold to hot. Random motion would need to organize itself. Broken patterns would need to heal without guidance. All of this is technically allowed, but so unlikely that it might as well be impossible. Think of a crowd leaving a stadium at the end of a game. Thousands of people pour out through many exits. The crowd spreads into the city. That process is easy. Now imagine the exact reverse. All those people, without communication, walking backward through the streets, entering the correct gates, sitting in the exact same seats at the exact same moment. Nothing stops it by law. But probability destroys the idea. The odds are essentially zero. This is why time feels solid and directional. It is not that the universe has a strong opinion about past and future. It is that large systems behave in predictable statistical ways. Disorder grows, energy spreads, information leaks, and with that the arrow of time appears. Even life follows this rule. Living systems look highly ordered, but they survive by exporting entropy to their surroundings. A body stays organized by producing waste heat and waste matter. The moment that process stops, entropy wins locally, and the structure falls apart. Life does not escape time's arrow. It rides on top of it. So when you ask why time refuses to run backward, the answer is quietly simple. The universe likes what is likely, and what is likely is spreading, mixing, and forgetting. The backward direction is not blocked. It is just buried under impossible odds. Time moves forward, not because it must, but because almost everything else would require a miracle made of perfectly coordinated atoms. And miracles are rare when numbers get large. That is the strange beauty of it. The deep mystery of time does not come from exotic forces or hidden clocks. It comes from the humble truth that when many things move together, chance becomes destiny. Outline. Entropy explains broken cups staying broken. Take a cup in your hand. It feels solid, reliable, familiar. Now imagine it slipping, falling, hitting the floor, and breaking into pieces. You don't pause to wonder if it will happen. You already know the ending. The cup will stay broken. What feels obvious in daily life hides a deep question in physics. Why does the cup not jump back together? Why does breaking feel final? The surprising answer is not that nature hates cups. It is something called entropy. Entropy is a word people often fear, but the idea is gentle. It is about how spread out things become, how energy and matter like to move from neat arrangements to messy ones. Before the fall, the cup is organized. The atoms are arranged in a very specific pattern. There are not many ways for the cup to be exactly a cup, but after it shatters, the pieces can lie on the floor in many positions, angles, and shapes. There are countless ways for broken pieces to exist. The broken state is not special, it is common, and nature strongly prefers common states. When the cup hits the floor, energy flows everywhere. Some becomes sound, some becomes heat, some becomes tiny vibrations that move through the floor and air. That energy spreads into millions of atoms around the room. Entropy increases because energy is no longer concentrated in one neat place. It is shared, scattered, and mixed. Now ask a strange question. Could all that energy come back? Could the heat in the air return to the cup? Could the vibrations reverse? Could every tiny motion retrace its steps perfectly? In theory, yes. The basic equations of motion allow it. But in practice, the chance is so small that the universe never bothers to try. Think of shaking a box of puzzle pieces. At first, they might form something recognizable. Shake the box more, and the pieces spread into random positions. Now shake it again and hope the pieces reassemble themselves into a set picture. You could shake forever and never see it happen. Not because it is forbidden, but because the number of wrong arrangements is overwhelming compared to the one right arrangement. This is what entropy really tells us. It tells us which states are likely and which are fantastically unlikely. A broken cup has many more possible arrangements than an unbroken one, so once it breaks, it almost always stays broken. This idea does not depend on cups. It applies everywhere. Ice melts in a warm room. It does not collect energy from the air and freeze itself. Perfume spreads through a room. It does not gather back into the bottle. Milk mixes into coffee. It never separates on its own. In all these cases, entropy is quietly increasing. What makes this so interesting is that the microscopic rules are not biased. At the level of atoms, motion can run forward or backward. Collisions look fine, either way. But when you have trillions of atoms, statistics take over. The universe starts behaving like a crowd rather than individuals. Imagine a crowd leaving a theater. Everyone moves toward many exits, spreading out into the streets. That happens naturally. Now imagine the exact reverse. People in the streets suddenly walk backward, enter the correct doors, and sit in their original seats. Nothing stops each person individually. But coordinating everyone without guidance is nearly impossible. Entropy is the reason crowds spread and never unspread. The broken cup is like that crowd. Each atom is free to move. But getting them all to cooperate again is the problem. Entropy measures how much cooperation is required. Low entropy means high cooperation. High entropy means everyone is doing their own thing. This also explains why damage feels permanent. Breaking, burning, aging, rusting. All of these are processes where energy spreads and entropy increases. Repair requires effort. You must add energy, guide the system, and push it back into a rare, organized state. Nature does not do this automatically. It only happens when something else pays the price by increasing entropy elsewhere. So when you look at a broken cup and feel that quiet sense of finality, you are sensing a deep law of probability. The cup is not cursed. Time is not angry. The universe has simply moved from a rare state to a common one. Entropy explains why broken cups stay broken. Not because going backward is impossible, but because the universe almost always chooses the path with the most ways to happen. Outline 3. Does memory require increasing cosmic disorder? Think about a simple moment. You see something happen, and later you remember it. That feels easy, natural, almost free. But memory is not free at all. Memory is physical. It lives inside matter. And the moment you realize that, a strange question appears. Does memory exist only because the universe becomes more disordered? Let's start gently. A memory is information. Information must be stored somewhere. In a brain, it is stored as tiny changes in connections between neurons, changes in chemicals, changes in electrical patterns. In a computer, it is stored as charges, magnetic states, or microscopic structures. In a notebook, it is ink arranged on paper. No matter the form, memory always needs a physical change. Now here is the key idea. To create a physical change, energy must move. And when energy moves, it spreads. That spreading increases entropy. Entropy is not about chaos in a dramatic sense. It is about how energy and matter distribute themselves. More spread out means higher entropy. So every time a memory forms, something else pays the price. Imagine taking a photo. You press a button and the image is saved. But behind that simple action, electrons move, circuits heat up, energy flows into the surroundings. The camera warms slightly, the air around it warms slightly. The entropy of the universe increases. The memory exists because disorder increased somewhere else. Now think about the brain. When you learn something new, neurons fire, chemicals move, heat is produced. The brain consumes energy and releases waste heat. That heat spreads into the body and then into the environment. Memory is written, and entropy quietly rises. This leads to a deep connection between memory and time. We remember the past, not the future. That seems obvious, but why? The reason is not psychological, it is physical. You cannot remember the future because memories require entropy increase, and entropy increase defines the direction of time. If entropy were not increasing, memories could not form. The brain would have no way to create stable records. Information would not stick. Learning would be impossible. In a perfectly reversible universe, nothing could truly be recorded, because recording requires irreversible change. This means memory is not just something that happens inside minds. It is a process the entire universe participates in. Every remembered moment slightly increases cosmic disorder. Now consider something interesting. Records of the past exist everywhere, not just in brains. Fossils, photographs, scratches, light traveling through space, even patterns in radiation. All of these are physical records, and all of them exist because entropy increased when they were created. Take a footprint in sand. A foot presses down, rearranging grains. The footprint holds information about the past, but creating it required energy, and that energy dissipated into the sand and air. Over time, wind smooths the sand. The information fades. Entropy keeps increasing, and the record slowly disappears. This shows something important. Memory is temporary unless work is done to protect it. Information leaks away, details blur. Heat erases fine structure. The universe is always trying to forget. Now ask the big question. Does the past still exist? In one sense, the past survives only as memory and records, and those records are incomplete, imperfect, and constantly degrading. There is no cosmic archive storing a perfect copy of yesterday. There is only what entropy has not yet erased. This also explains why we cannot perfectly reconstruct the past. Even with advanced tools, some information is gone forever. Tiny details have been mixed into the environment as heat. Once that happens, reversing it would require gathering unimaginable amounts of scattered energy and information. The odds are effectively zero. So memory does not just depend on time. Time depends on memory, or more precisely, both depend on entropy. As entropy increases, time gains a direction, and memory becomes possible. Think about what would happen in a universe where entropy did not increase. Everything would be perfectly reversible. Any change could be undone. But in such a universe, no record could last. No learning, no history, no nuvith. The moment something happened, it could unhappen just as easily. Nothing would stick. In that universe, asking about the past would make no sense. This gives memory a strange role. Memory is evidence that the universe is moving in one direction. Every remembered thought, every recorded image, every written word is a small arrow pointing forward in time. Even forgetting follows the same rule. Forgetting is entropy at work again. Neural connections weaken. Chemical patterns fade. Information spreads and dissolves. Forgetting is not failure. It is physics. What about the future? Why does it feel open? Because there are no records yet. No memories can exist without entropy increase, and entropy increase has not happened for future events. The future has many possible paths. The past has only records, and those records grow fewer and fuzzier with time. So does memory require increasing cosmic disorder. Yes. Quietly, inevitably, every memory is written in exchange for a little more disorder in the universe. The universe allows memory, but it demands payment. And that is the deep, playful irony. We understand the universe by remembering it, but the act of remembering is slowly making the universe forget the fine details of how it used to be. Memory exists not in spite of entropy, but because of it. Outline 4. Is the past stored or erased? Think about yesterday. It feels solid, fixed, untouchable. You are certain it happened. But where is it now? Is the past stored somewhere in the universe like files on a hard drive, or is it slowly being erased, detail by detail? At first it feels obvious. The past must exist. After all, we have memories, photos, scars, fossils, and records. These things feel like proof that the past is still there. But look closer. All of these are not the past itself. They are traces. They are physical marks left behind by events, and traces can fade. The memory in your mind is not yesterday itself. It is a pattern of matter that exists right now. A photograph is not the moment it captured. It is ink or pixels arranged in a certain way today. A fossil is not the ancient creature. It is a rock shaped by time. The past does not sit inside these things. It echoes through them. So the past is not stored as a perfect copy. It is reconstructed from what remains. Now think about what it takes to store information. Information must live in matter. Matter must be arranged in specific ways. To create that arrangement, energy is used, and energy spreads. This spreading is called entropy. Every record of the past exists because entropy increased when that record was made. This already hints at something strange. If recording the past increases entropy, then recording everything perfectly would require infinite control. The universe does not do that. It records some things roughly and then lets entropy blur the details. Think of writing on paper. You can write a sentence and it stays readable for years, but leave the paper in sunlight, water, fire, or time, and the ink fades. The record degrades, information away. That leaking is entropy at work again. Now imagine the universe trying to store every detail of every moment, every vibration, every photon, every atomic motion, to preserve that perfectly. Nothing could ever mix, spread, or dissipate. But mixing and spreading is exactly what the universe does best. Heat flows, sound fades, light scatters, patterns smooth out. The universe is not designed to keep fine details forever. This means the past is not being carefully archived. It is being slowly erased. But erased does not mean gone instantly. It means information becomes harder to recover. Details dissolve into randomness. Like a drop of ink in water. At first, you can see the shape. Then it spreads. Eventually, the water looks uniform. The ink is still there, but the information about its original shape is lost. This is a powerful idea. The past is not destroyed. The atoms still exist. The energy still exists. But the information that defines specific events gets mixed into the environment. Once mixed deeply enough, it cannot be reconstructed in any practical way. This explains why we cannot replay history perfectly. Even if we knew the laws of physics exactly, we would need impossible precision about the current state of the universe. Tiny errors would explode backward in time. Entropy makes the past fragile. So is the past stored or erased? The answer is both, depending on what you mean by stored. The past is stored in a rough, incomplete way. Big things leave big traces. Supernovas leave light echoes. Earthquakes leave geological marks. Human actions leave buildings, words, and tools. But fine details vanish quickly. The exact sound of a voice, the precise air motion in a room, the exact heat pattern of yesterday afternoon. These are gone. The universe keeps the headline, not the fine print. This also explains why some moments feel more real than others. Events that strongly disturb matter and energy leave stronger records. Quiet moments leave almost none. A whispered word disappears faster than a shout. A thought leaves less trace than a collision. Over time, Even strong records weaken, mountains erode, stars burn out, atoms decay. Nothing is protected forever. Now think about time itself. We experience time as a story with a past, present, and future. But the story only works because records exist. If all records vanished instantly, the past would feel unreal. Without memory or traces, there would be no evidence anything happened. In that sense, the past exists only as long as something remembers it. This makes the past a moving target. As time passes, the amount of information about earlier events shrinks. The past becomes simpler, blurrier, more symbolic. History becomes stories instead of data. So when you ask whether the past still exists, the honest answer is subtle. The universe does not keep a perfect archive. It keeps leftovers, and those leftovers are slowly dissolving. This is not tragic. It is simply how a universe with entropy works. Order fades. Details smear. Only broad patterns survive. And from those patterns we reconstruct meaning. The past is not sitting behind us, frozen and complete. It is being rewritten every moment as records decay and memories change. What remains is not what happened exactly, but what entropy is allowed to survive. So the past is neither fully stored nor fully erased. It is partially remembered, partially forgotten, and always slipping further away. Outline 5. From shuffled cards to vanished histories. Take a deck of cards. Brand new, perfectly ordered. Suits grouped, numbers aligned. That order feels intentional, rare. Now shuffle the deck once. The order is gone. Shuffle it again. Any memory of the original arrangement disappears. You could shuffle for the rest of your life and never see that exact order again. The simple game with cards quietly explains something much bigger than card tricks. It explains why histories vanish. When a deck was ordered, it represented one very special arrangement. There are not many ways for a deck to be perfectly sorted. But once you shuffle, the number of possible arrangements explodes. There are more possible shuffled states than there are seconds since the universe began. So when the deck becomes random, it is not lost. It is simply one of an enormous number of common states. This is the heart of entropy. Entropy is about how many ways something can be arranged. Low entropy means few possibilities. High entropy means countless possibilities. Nature moves from few to many because many is easier to reach. Now zoom out from cards to the real world. Every event is like a shuffle. Energy moves, particles collide, information spreads. A clean, precise state becomes a mixed one. And once mixed deeply enough, the original pattern cannot be found again. Think about history. A moment happens, a conversation, a decision, a discovery. At that instant, the universe has a specific configuration that immediately heat flows away. Sound waves spread, light scatters, air molecules bounce. The information about that moment begins to dissolve into the environment. At first, the history is clear. People remember it. Cameras record it. Objects show evidence. But as time passes, memories fade. Records decay. Files corrupt. Details disappear. History becomes simplified, like a deck of cards shuffled beyond recognition. This does not mean the past is destroyed. The atoms still exist. The energy still exists. But the arrangement that once told a clear story has been scrambled. The story is now hidden among countless other possibilities. This is why reconstructing the past is so difficult. Even with perfect laws of physics, you would need perfect knowledge of the present. One missing bit of information ruins everything. It is like trying to unshuffle a deck without knowing the exact sequence of shuffles. Guessing will not work. Now think about something more dramatic. While city burns, buildings collapse, people flee, the event leaves strong marks at first. Smoke in the air, ruins on the ground, news reports. But decades later, new buildings rise. People move on. Records are lost. The strong marks weaken. Eventually, only fragments remain. History thins out. Go further back. Ancient civilizations, prehistoric life, early stars. The further you go, the fewer details survive. Not because nothing happened, but because entropy erased the fine structure. The universe remembers less the further back you look. This gives time its strange feeling. The present feels sharp. The recent past feels detailed. The distant past feels vague. This is not just human memory failing. It is physical memory fading. Entropy does not target meaning. It does not choose what to erase. It simply spreads energy and information until patterns blur, like ink in water. The shade disappears even though the ink remains. Now return to the deck of cards. If you had filmed every shuffle perfectly, you could, in principle, reverse them. But filming requires storage. Storage requires energy. Energy creates heat. Heat increases entropy. The act of recording the shuffles adds more mixing to the universe. Perfect history demands infinite control, and that is not available. So histories vanish, not because the universe is cruel, but because it is generous with possibilities. It allows systems to explore many arrangements, and once explored, there is no reason to return to one special case. This also explains why the future feels open. There are many possible future arrangements. None are recorded yet. The past feels fixed because only one path was taken, and traces remain. But those traces are fragile. Over time, the universe becomes more shuffled. Not just cards, but stars, atoms, information, and memories. Order gives way to variety. Precision gives way to averages. Stories give way to statistics. Yet something beautiful remains. Even as details vanish, large patterns survive. We may not know every card's position, but we know the deck is shuffled. We may not know every event in the early universe, but we know its general story. Entropy erases the fine print, not the headline. From shuffled cards to vanished histories, the message is the same. The universe does not run backward to restore old arrangements. It moves forward into richer mixtures, and in doing so, it slowly lets the past fade, leaving behind just enough to remind us that it once existed.